Okay, so let's move on to solve the challenge problem of the chapter 22, the last chapter. So the first question is we want to evaluate 1 plus this one, right? So let's examine it's 1 plus x. Okay, so now x is equal to the 8 over the 2 plus the 8 over the 2 plus forever, right? So you can see if this section is 8, so 8 over 2 plus, then this section is also x, right? So now let's solve the x. So we can see the x squared plus the 2x minus 8 equals to 0. So we have the x plus 4, the x minus 2 equals 0. So x1 is negative 4 and the x2 is 2. But we know this part, okay, this part is a positive number, right? So we know x greater than 0. So the only solution is x equals to 2. If x equals to 2, then we can have the original s is 1 plus x equal to 3. Next. So if xy is equal to this, we want to find this, right? So we want to find x squared plus y squared. So x squared y plus xy squared plus x plus y. So we can see this one is the xy, right? X plus y, then plus x plus y. So we have the xy, x plus y plus 1 equal to 63. So now we can say if xy is equal to if xy is equal, sorry, this is xy plus 1. So xy equals to the 6. So the 6 plus 1, x plus y equal to 63. So we can get x plus y equal to the 9. Once we get x plus y equal to 9 and the xy equal to 6, now we can solve the x squared plus the y squared is x plus y bracket square minus 2xy. So it is the 9 squared minus 6, 2 times 6. 9 squared minus 2 times 6 is 81 minus the 12. So it's the 60 minus 70, 69. Okay, then next. So consider the equation of this. We want to find the sum of the roots. So by the Vieta theorem. So that's the roots of the p and the q. So the p plus q is negative 4, and the b sum of square of the roots. So the p squared plus q squared. And we know the p times q is 1, so the p plus q of the square minus 2pq is equal to the 16 minus 2 is 14, and the c is find the cube. So we have a recursion here. Okay, let me show you. So we have the x squared is equal to the negative 4x minus 1, right? So we know pq are the possible of the roots, right? So let's see. So the x of the n is equal to the negative 4xn minus 1, then minus the xn minus 2. So that's why the pn plus the qn is equal to the negative 4, the pn minus 1 plus the qn minus 1, and then minus the pn minus 2 plus the qn minus 2. Okay, so if we define the Pn and the Qn as Sn is the negative 4Sn minus 1 minus Sn minus 2. So now let's see. So the S3 is equal to negative 4S2 minus the S1. Now we know this is the S2. This is the S1. So now we can solve the negative 4 times the s2 is 14 minus the s1 is negative 4, so it's the negative 56 plus 4, so it's negative 52. Okay, so you can see that you can solving those are pretty general format using the recursion. This one, so we have a set of the equation set. Okay, so for find the real n for which this is satisfied. Okay, so 1 and 2 and 3. This one has no solution, right? So the quickest way you can see, you have the if we 1 plus 2 plus 3, if we add them together is 1 plus 1 of the x plus y plus z, then equals 3. So if n equals negative 1, right? So the 0 times the x plus y plus z need to be equal 3. Definitely there is no solutions for this. Okay, and this is the quickest method 1, but method 2 is you do the linear elimination to solve it. Okay, so that's using the n times the 3 minus the 1. It tells you the n squared z minus y equals to the n minus 1, and then we have the 2. This is a 4, and let's see with the 2, ny and z plus ny is equal to 1. So now you can times n again, right? So this is the 2, then you can see the 4 times n plus 2, then becomes the n cubed plus 1 to the z, then equal to the n squared minus n plus 1. Then you can see this is the arbitrary n, right? So n equals negative 1. There is no solution, right? N equal negative 1, here is 0, and here is equal to the 1 plus 1 plus 1 is 3. So there's no way. So the answer also getting to the n equal negative 1. Both of the method are working. Okay. Next, if the area of the three sides of a rectangle box are if the areas of the three sides of three sides of a rectangle box are this one, so we can see we have the three sides x, y, z. Their area is the x times y equals 24, then y times z equals 32, and the z times x equals 36. The question is asking the volume is x, y, z. So this one is, if you only want to know x, y, z, right? So you can see the 1 times 2 times 3 will give you the x squared, y squared, and z squared equals to the 24 times 32 times 36. So you take the square root, okay? So then you take the square root of the 24 times 32 times 36, okay? Then this will give you the answer of the 96 root 3. Next, so we know the a minus b is this. We want to solve what is ab. We also know this. So the a cube minus b cube, the difference of the cube is a minus b. Then we have the a squared plus the b squared plus ab. Then we can further to do is the a minus b of the square, then minus 2ab, so we need to plus 3ab, then equals 120. So now let's put in 3, and the 3 squared plus 3ab is equal to 120. So then we know the 3ab plus 9 is equal to 40, right? Now you can see the ab is 31 over 3. Next. So this is a very special thing, okay, the number and the square. So you can see if x plus x1 of the square, so the 2ab, the 2 times x over x is 2. So this constant, that's why I make it special. So this one is x plus 1 over x of the square plus 2, right, equals to 9 plus 2 is equal to 11. So that's why the x plus 1 over x is plus minus root 11. Next. So if we noticed this in the previous ones. So A is, let's show the x cubed plus the x cube over 1 over x cubed is x plus 1 over x, right? Then it is the x squared then plus the 1 over x minus 1, right? So that's why you can see this is the A, then this is the x plus 1 over x of the cube minus 2 minus 3. So that's why it's A, and A squared minus 3 is A cubed minus 3A. Okay, now we want to use the Vaida theorem to give you a general form. Okay, let's see if the x plus the 1 over x is a, right, and the x times 1 over x is 1, right, means the x and the 1 over x are the roots of the t squared minus the at then plus 1 equals to 0, right? So now we can see the t squared equal to at minus 1, right? So now we can see the Tn is equal to Atn minus 1 minus the Tn, right? Tn minus 2. So, and x and x and the 1 over x are its roots, right? So xn plus 1 over xn, right, is equal to Sn is equal to the A times Sn minus 1, then minus the Sn minus 2. This is the recursion, okay? So again, with this recursion, we know D, right? Let's see. So the S4, right? D equals S4 is equal to the A times the S3 minus the S2 is A times what S3 we already have is the A to the 3 minus the 3A, right? And the S2 is B, right? Is A squared minus 2. So minus the A squared minus 2. So what we have is the A to the 4th minus the minus 3A squared minus 4A squared plus 2. So this is the D, okay? Now we also can solve the E, right? Let's see the E. C will be the E. E means the S5 is equal to A times S4 minus S3 is equals to A to the 4 minus the 4A squared plus 2, then minus S3. S3 is A cubed minus 3A. The A cubed minus 3A. Okay, so this one will be A the 5 minus 4A cubed, then minus the 5A cubed plus 2A plus 3A plus 5A. Okay, now the last problem is asking you whether this one always possible, right? Expressed in terms of this. That's yes, right? You can see because there is a recursion. Okay, because there is a recursion, so that's why it is always possible. So that's why the Sn is equal to Asn minus 1 and the minus Sn minus 2, right? So we know the Asn minus 1 can be in terms of the A, and the Sn minus 2 can be also in terms of A. So final can be in terms of the A. Okay. So next, we want to solve this problem. So now let's see x equals this, right? X equals 3 plus 1 over 2 plus, now this section, okay? No, this section becomes the x again. Okay, so it's 1 over x. So that's why now we can see x3 plus it's the 2x plus 1x over this, right, equal x. Now we can try to solve the equation. Okay, uh, so when we simplified it, it's 2x square plus x is equal to 6x plus 3 plus x. So we get it is the 2x square plus minus 6x minus 3 equals to 0. Okay, solve this is delta is equal to 36 minus the plus the 12 times 2 is equal to 60. So the answer will be the 4. The x equals 4. Then it is negative this plus minus 60 because we know x is greater than 0, right? So x greater than 0 means x equals to the 4, 6 plus the 2 root 15 is equal to 2 of the 3 plus root 15. Okay, next. So for this problem, so we can write as 2 plus 3 times 1 over 2 plus 1 over 2 plus something, right? So we know if we want to solve this a, right? So we can see a equals 2 plus 3 times x. Okay, then we set up equation of the x. So if this is the x, so x equal to 1 plus 2 plus the x. So now let's solve the x is x squared plus the 2x minus 1 equals 0, right? So we can solve the x is delta is 4 plus 4 is 8. So the x equal to 2 minus 2 plus minus 2 root 2. So we know x greater than 0, right? So the x equals to the root 2 minus 1. If x equal to root 2 minus 1, you can insert back. So it's 2 plus the 3 root 2 minus 3 is equal to 3 root 2 minus 1. Okay, so this is the answer. Okay, so for this problem, we are going to investigating if we want this one to, if we want in which the contents are asked to simplify the equation to a form where a, b are the integers, a, b are integers, right? Okay, so we want to write a math problem for that. The answer of the problem is also integer. So we want to the a plus root b and plus the a minus the root b is also belong to an integer. Okay, so which of the following is true? So you can think, okay, if this one is an integer, so there are two ways to do it. Okay, I talk about the method 1 first. If you notice this one, right, so we can see it is the p plus root q, the square, equal to the a plus root b, right? And the p minus root q of the square will be equal to a minus root b. Let's expand it. So p squared plus q, okay, plus the 2p square root of the q. And this one is p squared plus q minus the 2p root q. Okay, so now you can see here is the plus, here is the plus, right? And a is the same. Now you can see we have the a equals the p squared plus q, and the square and b equals to the 4p squared q. Okay, so now this one can tells us the b over 4 is p squared q, and a equals to p squared plus q. And also it tells us the we can do we can form a quadratic of the p square. So the q is equal to a minus the p square. So that means the p square a minus the p square equals b over 4. So now we can see the p to the fourth, right, minus the ap square plus the b over 4 is equal to 0, because p should be an integer, right? So that means if we want to solve this equation for as a p square, so we know that is a square minus b, and this one should be the, we need the, at least this one should be integer, right? So that's why the a square minus b should belong to a perfect square, belong to n square. So now let's see the results is a square minus b, so the answer is b. Okay, this is the method 1, and we also have the method 2, is just simply to square on both sides. Okay, let's see, the s is equal to the a plus root b plus the a times the root b, so we have the a plus root b plus the a minus root b s square is equal to the plus 2 of the a square minus b. So this is gone, right? So this is integer, we need this one to be integer, so that's why a square minus b is belong to a perfect square. Okay, so that's it for the first section of this chapter. I will recording the second part. Okay, thank you, bye.